All right, well, I started the recording. So good afternoon, everybody. Welcome to Math 140 for the spring semester. My name is Matt Sokol, and I'll be your instructor for the course. And I'm incredibly excited to be teaching this course for you guys. I think what you'll notice as the semester goes on is that I really, really love statistics. It's one of my favorite subject areas. And so that I hope that by the end of the semester, you guys kind of like enjoy it as well. All right, so this is our Blackboard page. So, to access the course, you've all done this, right? You log into your Blackboard and you'll see all your course listed, and hopefully you're not teaching, or taking 4 math courses, or hopefully maybe you are, I'm not sure. But here's our course. So we'll click in here. And you'll always log into right on the announcement page. Now, how many people, if you could just shoot in the chat, let me know how many people got the email that I sent out, just the announcement emails. Do people get those? I got one. Great. Thank you for that in the chat. I appreciate it. What I do is you'll get at least one announcement from me every week, and I'll also click and send it to you via email. Just, if you didn't get it, you might want to check what email you have listed in the classroom. It'll just be important stuff like, hey guys, this is up, or, download the homework, or anything that's important, or what's coming up for the week. So just, just look for that in your email. All right, the next tab over here on the side is this tab called the Outline and Overview. So I'm going to click on that. In here, you should see our course syllabus. So how many people, just out of curiosity, have clicked and downloaded that already? One person, a couple people did. All right, so what I want to do is I want to go through it in detail with you now, just so you understand the expectations of the course, how things will be run, things like that. So I'm going to click this and download it here. And can everybody see? Everybody can see the syllabus there on my screen, okay?
Yes.
Okay, thank you. I appreciate the hopping on the mic too. I appreciate that. All right. So as I said, my name is Matthew Sokol. I'll be your instructor for the course. So my office location in my office hours, if you ever want to meet and just chat about stuff, my office, it's so funny I say office location, but my office is held via Zoom, okay, like much of the world these days. So if you go back in the classroom, you'll see this tab here called office hours. And here's the link for my office hours. So I will be in front of my email every Tuesday, 8 a.m. to 1 p.m. The only thing I ask is if you do want to stop by my office hours, you just shoot me a quick email, like giving me a 5-minute heads up. I'm not going to leave the Zoom link open for 5 hours. So just shoot me an email, be like, hey, Matt, I want to, meet. And I will, respond to the email and say, okay, I'll meet you in my office hours in 2 minutes. And then we can, go through any questions you have. If those hours don't work for you, the other days I can accommodate you on other times, but the other day that's best for me is Fridays. You guys will find out in about 20 minutes when he goes down for his first nap, but I have a young toddler, and so I have to juggle that with him and meeting with students. So if those hours don't work from you, we'll find something that does work for you. Okay. Just out of curiosity, does anybody else have young children at home? My wife, if you ask her, she'll say she has 2 young kids at home. Everybody get that joke? It was a reference to me.
Yes.
Thank you for the laughs. Yeah.
Very good.
All right. All right. If you ever want to get in contact with me, the best way to get in contact with me is via email. And here's my work email listed here. So I check my work email. Gosh, I usually have it open on my computer Monday through Friday from 6 in the morning till 8 o'clock at night. And I check it almost every other hour on the weekends. So if you ever want to get in contact with me, shoot me an email. You'll get a response from me rather quickly. Okay, so there's our website to log into the SUNY learning system. Okay, so the textbook for this course. I have some good news. We're going to be using a free online open source textbook. Is that great or what?
Yes.
Yep.
Yeah, yes, free, right? You don't have to pay $100 for a textbook that you'll probably only use a couple times. But so if you go back in our classroom, there's this link in here called the textbook link. Okay, so I'm going to click that. And there's this link to our textbook here. And if you don't like online textbooks, you can order a print copy. I think it's like $30 on Amazon or something. Yeah, you can even buy it used for $22. It's okay. You bought the hard copy. That's great. Did it come really quickly, Beatrice? Yeah, you can buy the hard copy. That's perfectly fine. It's pretty cheap if you want to buy that. That's just the cost of printing it for you, basically. But the course, that being said, it is actually designed to be consumed online. So, you know, if you click on some of the links for the section, there'll be like multimedia stuff in here, like solution that doesn't actually translate well perfectly into the textbook. But it's okay to have a hard copy. I own a hard copy. It's totally fine. We're going to be using our textbook primarily as an additional resource. The best way that my lectures are exhaustive in the sense that anything I would ask on an exam or a homework I'll cover in class, and the textbook is just going to be extra extra reference if you need it later on. Okay, the textbook also covers some things that I won't cover, but I'll let you know when we cover a section, you know, what textbook sections to reference on that. Okay. The one thing you will need in this class is a graphing calculator. How many people have a TI graphing calculator?
I do.
Okay. It doesn't matter if you have a TI 83, a graphing calculator that looks like this, or a TI 84. Give it a second to load up here. Or a TI 84, but you will need one of these. They are expensive. So I wish, I'm sorry. Come on, what are you doing? I wish they weren't. Honestly, the best way to order it is actually to buy like a used one off Amazon if you don't have one. Like you can go to Amazon and type in like a TI 83 and TI 83 calculator, and like you can get them used for like $10 or something. So I'm sorry if you've already ordered it. And let me see, sorry, did you say a TI 83 is perfectly okay or TI 84 is perfectly okay? So here's the thing. You could actually do the class without a TI calculator. Like here's how class is gonna basically run. Whenever we introduce a new topic, I'll be like, okay, hey, this is how you do it by hand. And then we'll go through the painstaking process of doing the calculation by hand. And then I'll say, okay, well, you know what? In the real world, nobody really does it by hand. So let me show you how to use your graphing calculator. And, you know, when you go to do the homework and on exams, you're free to use the graphing calculator. So I can also show the class if people are interested, if they don't like the graphing calculator, how to use Microsoft Excel to do some of the stuff. But in all honesty, the graphing calculator is fantastic. So what I'll do in class is I'll load up both of these emulators that you see on the screen and show you how to do it with the TI 83 and then how do you do it with the TI 84, just because I know people have different ones. Okay. So sorry about the graphing calculator. I wish they weren't expensive. You know. Any questions about the graphing calculator otherwise?
No.
Questions? Okay. Trust me, I hate to say this, but they make the class a lot less stressful. Okay, like Yeah, you guys will see. Like next week when we start doing stuff by hands, everyone will be like, oh my God, Matt, that was so brutal. And then I'll be like, well, okay, don't worry. Now let me show you how to do it in the calculator. And everyone will be like, why didn't you just show us that first? Okay. But believe me, they're worth it, at least for this course. Okay. And then just the remote technology requirements, Zoom. So I don't know if some of your instructors ask you to turn the camera on. Some do, some don't. For me, it's not a necessity. What I'll do, you'll notice, is like I'll start class every day with the camera on, and I'll just, I'll say hi to people and I'll shoot the breeze with people for a little bit before we get started. You're welcome to turn your camera on or not. Totally okay with me. All right. All right, let me talk about the course description real quick. So this is a general introduction to statistical methods for students in all academic disciplines. And that's what I like love about statistics. No matter what field of study you're in, statistics is just applicable to every area of study at the collegiate level. Psychology, business, mathematics, obviously. One of the things, I probably shouldn't say this, but like one of the things that's really hard about teaching some of the math courses is really hard to see like how this is really useful in the real world. And like, that's not the case with this course. Pretty much every day of the class, we're going to learn something and you're like, wow, okay, yeah, that's useful in the real world. Or I'll come to class and I'll say, hey, here's some real world data. Let's investigate it. And it's I have a graduate degree in statistics. It's just a fantastic field. So topics include descriptive methods in the presentation of data, a thorough treatment of the basic concepts of probability. That's a really fun section. Techniques of statistical inference and decision-making through hypothesis testing, methods of a correlation and regression analysis, and the application of non-parametric methods in various subject areas. And don't stress if some of this stuff you're like, what the heck is hypothesis testing? What is non-parametric methods? I have no idea. Don't stress about any of that right now. By the time we cover these topics, I promise you I'll present it in a way that it's very, very easily consumable and understandable. Okay, so I break the course down into 5 sections. I'm going to cover this in my first PowerPoint in more detail. So I'm going to skip this topic outline for now. But what you can see next here is I have a course calendar where everything is broken down. We're going to pretty much follow this course calendar to the T. We might change things around like by one day at most, but if anything were to modify, I'll let you know. So you can see what I have here is I have the topics we're going to cover in class that day, and then the corresponding textbook section. So, like after class today, if you want some additional reference, you can go check out textbook sections 1.1 and 1.2. And then down along the side, you can see the due dates of our homework assignments. And then you can also see I have exams listed here. Okay. So you'll notice here, like in our schedule, there's 4 exams, and you'll notice before every exam, I'm going to have a review day. So to get you ready for the exam. And basically what we'll do during review days is, we'll spend 2 hours being like, okay, this is what test questions are going to look like. Let's just do practice and practice and practice for you and kind of review everything we've covered in the previous classes. Okay. What you guys are probably really interested on right now is, how your grade is going to be determined. So course grading. All right. So let me just talk about this. Your grade in this class is made up of 2 components: homework assignments and exams. Okay. I'm answering a lot of my questions. Oh, good. Yes. If you have any questions while I'm going, totally just stop me. Otherwise, I have this problem where I just ramble on for 2 hours. Okay. And nobody likes that. Okay. My poor wife has to listen to me do that all day. So you guys, if you guys have any questions, just stop me. Yeah, is the exam and homework due date same day or what? So like if you look here, like with this one right here, like exam 1 and exam 2, is that what you're asking? Are they the same day? Is that what you're saying? Yes, yeah, they are. So what you'll notice is I have homeworks due on every exam day. Basically what I do is I use these homeworks to help you also study for the exam. Um, so like basically, like for example, homework number 2 is going to be a lengthy homework that's going to give you a lot of questions that are going to be like on exam number 1. I'm also really loose about help with questions on the homework. So what I mean is during review day, if people in the class are like, "Hey Matt, homework question number 3 is a killer. How do you even solve it?" Like we'll work it together as a class. That's not a big deal. Okay. Okay, so go in here. So there's going to be 7 graded homework assignments in this class, each worth 50 points. And you can see their due dates listed here. So these assignments are going to be posted in Blackboard at least 1 week before their due date. And let me go to Blackboard real quick. You'll notice in Blackboard, I have this tab called Homeworks. And I already have the first homework posted there. So what it is there's 2 files here. There's a Word document and a PDF file. So what you'll do is you'll download the homework assignment, and you can either do the following things. You can print it out and handwrite your answers in, which is totally fine. Or you can download the Word document and like type your answers in if you want. Whatever works for you. I have no issue with either one of those. And then when you go to ready to submit the homework, this is a real big issue for me. And I do not accept homework via email. So what you'll do is you'll click this file here. Give me 1 second, Melissa. I'll answer your question in 1 second. And so to go back, you'll click when you're ready to submit your homework, you'll click on this. You'll browse to wherever you have your file saved. You'll attach your file, and then you'll hit submit to me. Okay. And then I will grade your homework like the next day after it's due. Melissa, to answer your question, no, the homeworks really vary. Some homeworks are going to be a lot longer than others. Like, I'll get to your question in a second, Jamie. They're not, I wish I could say that they're all going to be 10 questions or 8 questions. It just depends on like the complexity of the problems and how many, questions and topics we cover between homeworks, Melissa. If you write out your homework, how do we submit it? Okay, so there's a few ways. If you don't have a scanner, what you can do is you can take pictures on your phone and then submit those pictures. That's like the hardest way to do it, Jamie. But that's if you don't have a scanner. A lot of students actually do that. I would love it as a PDF. That would be like my preferred. If everyone were to submit it to me as a PDF, I would cry in happiness. Yep. 1 second, Robert. I'll go back to that. Let me get this other question first. So for homework assignments, you get credit for putting an answer. So here's the thing. I grade the homework. The more work you show me, the more opportunity I have to give you partial credit for problems. So you should definitely show as much work as you need to for the problems. Okay. Robert, to do the homework again, what you can do is you're just going to click on the assignment here. There's a link to it. You just click on it. Give me 1 second, Jamie. Then you browse to wherever you have the file saved. You attach it, and then you hit this little submit button down here. Jamie, it's graded on both. Let me just say one thing. I will start classes as we get closer to the due dates of the homework. I will start class and I will say, does anybody have any questions on the homework? And for example, let me load up homework number 1. Suppose people are people in class say, hey, Matt, homework question number 5. Geez, what's going on? Like, how do you answer that? I'll help you do that. The homeworks, I'm not like out to get you on the homeworks. The homeworks are just designed to help you learn the material. Does that help, Jamie? They're due after class. I think I set the due date. When did I set the due date for? I think they're set for 11:59 that night. So they're due after class. So you can come to class and ask me a question. All right. It doesn't matter to me, Melissa. The only times we're really going to have graphs is the first 2 homework assignments, and then we won't have many graphs after that. So if you want, like, you can do the graphs by hand and take a picture on your phone and submit the picture to me. You're welcome. Okay. All right. So these homeworks will be posted as a PDF and Word file. Download the time. You can type your work in or handwrite. It doesn't matter to me. The only thing I request is that when you submit me a file, okay, please make sure it's either a PDF, a doc, a JPEG. I can open up the iPhone photos. I don't even know what extension they are. They're like HETC, something like that. I downloaded because I noted HCEI. Thank you. Yeah, I noticed like a bunch of my students were submitting it to me that way. So I had to download like a conversion thing for it, but that's fine too. The only thing is I don't have a Mac, so I can't open like dot pages or whatever Macs save it as. I'm also like, as much as I love my iPhone, I am an anti-Mac person, mostly because my wife loves them and I have to be the antagonist there. So just make sure I can open it. Okay. You guys probably hear these jokes and think I have a terrible marriage, but I actually have a great marriage. Just a few joke in there for you. No LOLs in the chat. Okay. All right. We'll move on. The one thing that, no, it's too late. Too many pity laughs. It's fine. The one thing that I'm a stickler on is no late homeworks will be accepted. Okay. So the homework due dates are set. No late homeworks, the next day or whatever. You're going to get your homeworks will be posted at least a week ahead of time. So I don't accept any homeworks late. That being said, I will drop your lowest homework grade. Okay. So what I'm saying here is while there's 7 homeworks, I will just grade your best 6. Okay. So if you fail to turn in a homework or it's turned in late, I'll just give you a 0 on that, and that'll count as your dropped grade. Okay. There's no grading for class participation, even though I ask for the laughs and things like that. Class time is like my lecture for you to learn the material, but it doesn't impact your grade at all. All right. All right, then the exams. There's going to be 4 exams in this class, each worth 100 points. So exams are going to be posted to Blackboard and will be taken during class on the following dates. Okay, so these are the exam dates that we're going to try to stick to. What you'll notice on exam day, everyone always asks, like, how do exams go? What'll happen on exam day is there'll be a little tab that opens up in our classroom. There'll be a new tab here called exams, and you'll take your exam. It'll open up during class, and you'll take it during class time. We'll all log on to Zoom. And what'll happen is during the exam time is people will generally like have questions about the exam, like, hey, Matt, what did you mean by question number 4 here? So we'll use the Zoom as like while you're taking the exam to ask me any questions. But then your exam will be automatically graded and you'll know your exam score right at the end of class. Some other things, there'll be no makeup exams given in this class for any reason. However, I'm going to drop your lowest exam from exams 1, 2, and 3. Okay. Should you miss an exam, that's just going to count as your dropped exam. You'll just get a 0 on it. The only thing is all students are required to take exam number 4. Okay. Failure to take exam number 4 on the date that's listed there will result in a 0 on the exam. The exams are not cumulative. Like, you can look at the exams and it tells you what chapters they cover. Give me 1 second, Alexandra. But to be able to do well on exam number 2, you really have to understand the material for exam number 1, and so on and so on. Alexandra, there's 2 things here. If people get extended time, just let me know and I'll take care of that. It's not a big deal. Otherwise, you'll have 2 hours to do the exam. I very rarely, for as long as I've been doing this, have students who struggle to complete the exam in the allotted time. I write the exams honestly so that a student who really masters the material well can do it in an hour. Give me 1 second, I'll get your question, Melissa. And so, like, the extra time is, people want to slow down, read it very carefully, things like that. But I generally the 2 hours is allotted. But if people do have extended time, just let me know. Yep, I'll post practice exams, and also if you look back on the course outline schedule, I have a review day built in before every exam. Okay. All right. They're not all multiple choice. So what'll happen is they're going to be a mix between multiple choice and numerical calculations. Like maybe one question will be like, hey, what is the mean or average of this data set? And then you'll have to put in the average. Yep, just email me if you have extra time. There's no stress here. We'll take care of it when we get there. Yep. Honestly, no need to stress. We'll lower the stress level, right? We all have a bazillion stressors going on these days. MATH140 should not be one of them. No problem. The exam, so generally on exam day, what will happen is I'll open up the exam at 1 o'clock and then close it at 3 o'clock. So you'll have the 2 hours to do it. But again, I rarely have trouble, honestly. So on exam days, what'll happen is you'll log into Zoom if you have questions for me. Like on exam day, I will sit here in front of Zoom and answer any questions people have on the exam. Generally, like a lot of the questions are like, hey, Matt, I really don't understand the wording for question number 4. Or, I'll be honest with you, sometimes I make typos in the exam and people need clarification on that. That's where it's coming from. But if you find Zoom distracting during the exam day, you don't have to log into Zoom. You should log in at the start and then you can log off. No, if you finish the exam early, you can leave. Yep. No, you don't have to. And you'll notice, the exams are going to be open notes and open calculator for people, right? Because we're in the remote and learning environment. So the exams, there's no need to stress about it. It depends. So some exams, I'll be honest with you, are like 40 questions. Some are 20. It just depends on how much material we cover. And I promise you on review days, it is open notes, yeah. On review days, I'll get you ready for them. The one thing I will say about open notes, though, if you're like, oh, exams, I don't have to pay attention, I can just open notes. You'll blow your time just like flipping through your notes. So open notes is sometimes a curse and a blessing. Okay. All right. Yes, it is. Yep. That way you can also get some of my corny jokes and stuff too. So it's better for everybody. All right, numerical grades will be calculated. Sarah, to answer your question about quantitative reasoning, MATH117, a lot of the material is the same, but like we dig in much deeper into things and we cover a significant number of topics. Like Math117 is really like data analysis, a little bit of regression, and maybe you looked at the normal curve a little bit, but this course is much, much different. Okay. Okay, so your grade will be determined this way. Your best 6 homeworks, your best 2 exams of the first 3, and exam number 4. So your assignments are going to be worth 50% of your grade. Your exams are going to be worth 50% of your grades. There's 600 total points. I'm just going to take how many points you have in the class. So like, let's just say you have 500 points. I'm going to divide it by 600. That's an 83. So you'll get a B in the course. Okay. 85s and higher B plus, 75s and higher C plus, and so on. Here are the student learning outcomes if you wish to review them yourself. I'm not going to go through them. Here's the accommodation policy. Some people were asking about that. That's listed there. And information on Title IX. But that's the course generally, real quickly, real briefly, in 38 minutes. Does anybody have any last minute questions about that, or any final clarification stuff?
No.
Everybody feel like the course set up okay? A little less stress?
Yes.
Yes, thank you.
Yep. On exams and stuff, it depends, Beatrice. I can't give you an answer. Honestly, I think the first exam is 36 questions. And then some other, like the last exam is like maybe 15 questions. Okay. But I'm just going to, one last thing before oh, good. Yeah. My blood pressure hasn't been normal since June when my son was born. No, how many, the first exam is like 36 questions, and the last, it depends, to be honest with you, on the material. But on review days, I will get you ready for it. So don't stress about it. Okay. All right. All right, so let me just say one last thing before we get started in the lecture today. Normally, so we meet for 2 hours. Normally what I'll do is I'll lecture for 50 minutes and then we'll take a 10-minute break just to like recharge our batteries. But today, because I had to go over the syllabus and I want to cover material, we're going to skip the break. But normally know that we'll get a 10-minute break, all right? But since it's the first day, I hope everyone's okay with that. Okay. Let me go over just some other quick tabs in here. It depends, Jamie, to answer your question. Usually I do this syllabus stuff in about 25 minutes, but as you can see, we're running late. I'm at 140. So some of the stuff may or may not be on the first homework. It depends how far we get in the PowerPoint. So going back into the classroom here, you all know the online meeting tab. There's this tab here called course content. And you'll notice that I have here a folder for week 1. So when I click on here, you have these PowerPoints that I have listed here. These are the PowerPoints I'm going to use in class today. Just out of curiosity, did anybody download these yet? Has anyone looked at them?
Yes, I did.
All right, good. Generally, what you'll notice as the course goes on is like the first PowerPoint has a lot of stuff on it, but as you go later on in the class, PowerPoints are going to have less and less material posted in them, and you're going to start taking a lot more notes. Okay, so what you should always do before class is download the PowerPoint. I suggest printing it off. You don't have to, but have that handy, and I'll post them a week ahead of time. Then there's another tab here called recorded lectures. So at the end of every class, what I'm going to do is I'm going to take the PowerPoint that I used, and they'll have a lot of markups written in it, and I'll save it and I'll post it here in case you miss anything I wrote. And then I'll also post the recording from the class. So it takes me about 2-3 hours to get the recording up after class, but I will send you an email once the recording is up. Okay. And that's it. So, any last minute questions before I start the first lecture in our class? Okay, I'm just gonna stretch real quick and let's get started. Okay, so welcome to statistics, everybody. So what is statistics, right? Like, why are we taking this course? And stuff we won't do. And sorry for my handwriting. It's terrible. I apologize. But it's actually a requirement to become a professor. I don't know if you knew this. They test your handwriting, and it has to be bad. So what we won't do is we won't do problems like this, okay? Something like this. Does anyone know the answer to that problem? 2x plus 5 is equal to 15.
Yes.
What is it? I don't know. Yep. Yeah, that's like an algebra problem. This class isn't like that. Or something like this. If I have a right triangle here, you know, what's the length of the hypotenuse of that triangle? It's also
5.
Right, it's a 3, 4, 5 right triangle. We won't do geometry. We won't do trigonometry. We won't do stuff like this. The integral of x squared dx. Like, that's not what we do in this class, okay? What this class is statistics is the study, collection, analysis, interpretation, presentation, and organization of data. So what this class is all about data. Okay. And one thing I like to say that this class is it's how to take data and turn it into knowledge. Okay, that's how you take notes is up to you. This is what I suggest you do. Today's lecture is not really notes heavy. So what I would do today is pay attention to what I have to discuss. A lot of the stuff I write in the notes today are not overly important. And I will also share this with you. But like once we go later on in the class, you'll want to print out the PowerPoint slides and fill in any blank spots that I write into there. Or just take notes in a notebook and go back to the PowerPoint slides after. All right, does that answer your question, Jamie? Yeah, no problem. All right, so why study statistics, right? Like there's a lot of other math courses you could take. First, it's because data is everywhere, right? Like it's really hard for you to go a day in our society without getting bombarded with some type of numerical information or data, you know. Turn on the news, you know, today, and it's just, you know, information and numbers about COVID-19 are just thrown out there, you know, efficacy of the vaccines, how many people are getting sick. It's everywhere. So what I want you to do in this class is become an informed consumer of numerical information, like how to take data and correctly analyze it. Statistical decisions matter. Okay, statistical techniques are used to make decisions that affect our daily lives, as they affect our personal welfare. Here's an example. You know, we're all like, I can't speak for everybody, but like I'm chomping at the bit to get my vaccine. And, you know, after these pharmaceutical companies develop these vaccines, they send them to clinical trials. And really what they do is they employ epidemiologists who are really just like statisticians to determine the effectiveness of the vaccine. So it's like a mathematician at the end of the day who's determining if the vaccines that were developed are effective or not. And so we're going to learn some of these things in class, how the building blocks for how these decisions are made. And then this class has a ton of value. To make a group chat, Rebecca, are you talking about just the class or me?
I mean, either one. We could do both.
I will be honest with you. Feel free to make one without me.
Okay.
I'm trying to be as low tech as possible these days.
Okay.
Yes, yeah. I always like to say this. Don't friend me on Facebook.
Okay.
All right. So this class is value. So like no matter what field of study you go into or career you take, you'll make use of statistics. I always like to say this. Even if you want to be a psychology major, right? Like psychology, you need to take statistics for psychs. Like even a field like that is grounded in statistics. A few years ago, I went to a educational conference overseas, and every single panel I went to, it was just like, this is the method we tried. Here's the data. Here's the statistical analysis we did. So no matter what field you go into, you're going to need to use statistics. All right, so, yep, trends are everywhere. So if you look back in the syllabus, I said the course was divided into 5 sections of study. Okay, each is incredibly important. So what I want to do now is if you notice, I really briefly like skimmed through when I was talking about the syllabus, the topics we're going to cover. So here is where I want to kind of jump into that in a little bit more detail. Okay. So the first section is going to be introduction to statistics. That's today, sampling, data types, graphical and numerical summaries of data. I'll be honest with you, this section 1, I'm just letting you know ahead of time, is the most boring section. I'm just being honest. A lot of it is like, okay, how do you take an average? How do you find the median? How do you find the standard deviation? So I like to say, like, don't think as we go through section 1 of the course, that's what this class is about, because it really just lays the foundation for a numerical analysis of data. Okay. Section 2 is going to be about something called correlation and regression. We'll talk about that in a second. These 2 sections 1 and 2 here, all right, these are covered on exam number 1. And believe it or not, exam number 1 and your first couple homeworks are going to come a lot quicker than you think. Then we'll move into section number 3. This is about probability and what we call discrete random variables. I love teaching probability. It's my favorite topic. But I'll be honest with you, for some reason, probability ends up being the hardest topic for some reason. So don't get discouraged when we get to that section. This is exam number 2, is section 3, sorry about that. Section number 4 is about continuous random variables, the normal distribution, sampling distributions. This is exam number 3. And then our final topic is statistical inference, about 2 things called confidence intervals and hypothesis testing. And this is exam number 4 of our class. So that's just how you can see how the exams break out. All right, let me get in a little bit detail about the sections real quick. In section 1, we'll learn the process of statistics. That's what we're going to cover today. We're going to learn how to classify data types. Hopefully we get to that by the end. Then next class on Thursday, we're going to start talking about graphical methods for summarizing data. And then next week, we're going to talk about numerical methods for summarizing data. So like we'll learn about things like bar charts, dot plots, pie charts, histograms. We'll learn about things called the mean, the median, the mode. Have people heard of the mean, median, and mode before? Those words sound familiar?
Yes.
Yeah. But then we'll learn like things like the standard deviation. Like, have we heard of the term standard deviation before?
Yes.
But here's the thing, like, what is the standard deviation? You know, what's its uses? And then we'll learn things like the interquartile range. We'll learn all these different things. So again, just to be honest with you, it's a little dry. We'll use our calculator where we can. But this section 1 is what's called descriptive statistics. And it's just, descriptive statistics are just methods for organizing and summarizing data. It's just like this descriptive statistics is like the real basic stuff. Okay. Section 2 is a real fun section. So in this section, we'll learn how two variables are related to each other. You know, like a few years ago, I had a real big life moment. I bought my first house. No congratulations?
Congrats.
No, too late. It was too delayed. Forget it. You guys really hard exam 1.
Typing.
Yeah, you can blame the lag, Melissa, but it's fine. So what I'm saying here is, suppose there's two variables related to a house sale, okay? There's the house's selling price and the square feet of the house. Okay. And Robert's right, interest rates. Interest rates are really low, but I digress. So suppose we have these two things, right? How much the house sells for and the square footage of the house. Do you think those two variables are related to each other?
Yes.
Yes, they are.
Yeah, sure. Like how are they related, right? Like, do you think that the larger a house is in terms of square feet, the higher its selling price?
Yes, Professor.
Yep, just generally. Generally, that's the situation, okay? So anyways, what we're going to do in this section 2, is we're going to study this relationship, right? Like, it's not the only thing that affects the selling price, okay? So what we're going to do is we're first going to learn about this process called correlation, or this measurement, called correlation. And what that does is it measures the strength of that relationship between the two variables. And then we're going to learn about linear regression, which is how you model the relationship between the two variables. And we're going to make very, very heavy use of our graphing calculator in this section. So you really, I hate to be like a pain and re-hit this point, but by next week, hopefully you really have your graphing calculator with you.
Yeah, mine just got delivered.
Good, because we'll even start using it for some of this descriptive statistics stuff. Okay, but then when we get to this section, we're going to need it every day. Okay, and then in section 3, this is where we're going to learn. We're going to spend a lot of time on probability. I always like to say this. I used to live in Las Vegas, so we're gonna
Gamble a lot?
I'm sorry.
Where you gamble a lot?
I should not answer that on the recording, and I'm not saying anybody should go to a casino, but we will do the probability of some casino games in here, and then we'll talk about the probability as it relates to the real world. I think it's, as I said before, it's one of the harder topic areas, but it's also, I think, the most fun.
What is that formula?
Oh, that binomial problem. So this is. I know. Let me talk about that in a second. So, in this section, in section 3, we'll also learn about the first concept of a random variable. So, in mathematics, what letter do you generally let represent a variable?
X and Y.
Yep, X. So, in statistics, random variables or variables are going to have a very different meaning. We're going to tie them to what's called the probability distribution, and I'll teach you that. And it seems a little daunting right now, but it's actually pretty straightforward. We'll learn about things called expected values, and as I said, probability distributions. And then one of the things we'll learn is this thing down in the bottom corner of the screen there called the binomial distribution, or the binomial probability distribution. And you look at that formula. Does that formula right now look a little daunting, perhaps?
Yes.
Yeah. Yes.
Yeah, so this is an example of why the graphing calculator is going to be great. So what I'm going to do is in class, I'm going to show you how to do this by hand. once or twice. And then I'm going to be like, okay, well, now that we kind of have an understanding of it, let me show you how to do it very, very easily in your graphing calculator. Okay, so often in this class, we're going to look at crazy formulas like this, do them once or twice by hand, and then jump right to our graphing calculator. Okay. Section number 4. This is where we're going to continue our study of random variables, except we're going to learn about something called continuous random variables. We're going to learn about something called the uniform distribution. We'll learn about something called the normal distribution. And how many people might have heard of something called the bell curve?
Yes.
I've heard about it.
Yeah. Okay.
With like the 3-point and like the 6 or something like that.
Say that again.
It's like the one with like the 3 points, something like with like the numbers.
Looks like this, but there's a lot of interesting numerical values related to the distribution. And this section here is going to be the section that takes the most time. Okay, we're gonna spend a ton of time talking about the normal probability distribution and its applications. Honestly, we meet for 15 weeks. We're gonna be like for 5 weeks in section 4. It just takes the longest time because there's just so much to cover. Then we'll also talk about something called sampling distributions, which is one of the more applicable points of statistics. And just out of curiosity, kind of sidebar here, can anybody hear my son kind of crying in the background? Just a little bit.
No.
No.
No, not even a little bit.
Okay. I have a special microphone that's supposed to filter out voice. But what you'll notice is, and I apologize in advance, is that his afternoon nap time comes right around now. So you're going to reach a point during the semester where you just in the background, unfortunately, hear a crying kid. So just apologizing ahead of time for that one. But he's a great kid, actually. I'll even bring him on camera. There he is. Maybe I'll bring him on camera once. He's 7 months old. Yeah. No. Yeah. He was like that the first couple months. Oh, I'm just kidding. Please don't tell my dean that I said that about my child. But anyways, then the last section we're going to cover is section 5, and this we're going to learn how to form conclusions from data. This is called statistical inference, and there's 2 main topics we're going to learn in this section: confidence intervals and hypothesis testing. And you actually all have seen confidence intervals before and maybe not realized it. So, we had, I do reference political polls every once in a while in this class, but I will never, and I do never want to talk politics in this class, but, we had a presidential election a couple months ago, right? And it just seemed like there were always these polls that were coming out every day. And, you would see a poll and it would say something like this. The president's approval rating is 45% or whatever. I don't know. And then you would see something down in the corner that would say a margin of error of something like plus or minus 3%. Has anybody seen this before? Or heard this margin of error? Yeah, like that's just not a made up number. That's a statistical calculation, and I'm going to show you where those come from and how to calculate them. Like we will actually replicate some polls you see in the news and verify their data. Then we'll learn a process called hypothesis testing, which will show us how to take raw data and answer a research question. And this last section, section 5, is inferential statistics. Okay. And this consists of methods for drawing and measuring the reliability of conclusions about a population based on information obtained from a sample from the population. And this is what exam number 4 is based on. It's the last topics we cover. It tends to be the most advanced topics, but if you come to class every day and you pay attention, by the time we get there, it'll be really, really straightforward topic. All right. Before I go on now, because I've been going for an hour now, does anybody have any questions about the sections? No questions? All right. I hope after, hearing me talk about them, people are kind of like excited for the course. It's just like, it's a really good course and the topics are like incredibly interesting over the next 15 weeks together. Okay, so what I want to do now that we've kind of spent an hour going over the syllabus and talking about the course outline, now I'm going to hop into the beginning of like we're learning statistics now. So now is a good point if you haven't really been paying attention or taking too many detailed notes to kind of pay a little bit more attention here. Okay, so I want to hop into the process of statistics. Okay, so statistics you can think of, it's a branch of mathematics, right? Mathematics is a foundational science. So there has to be like a scientific process or a statistical method for statistics. And in our course, stats is going to be broken into a 5-step process. Okay, the first step in statistics is always to ask a research question. What am I trying to show with data? What am I trying to have data tell us? The good news is, right, this is an entry-level statistics course. So I'll always bring this to class. Okay, so a lot of times we'll start class and I'll be like, okay, here's the research question we're looking at. As you go further on in your academic career, especially if you go to graduate school, you'll develop your own research questions to answer. The second step in the process is you need to design a study and collect data to answer your research question. This also Matt will do for you, I will do. Okay, there's whole graduate level courses called experimental design and data collection process. So what I'm going to do at the end of this lecture is, show you or talk to you about how different data collection processes, but in general in class, I will always bring the data. I'll say, okay, now here's the data we're going to look at. The third step in the process is you're going to explore the data. This is section 1 of our course. Okay, this descriptive statistics. Okay, you're going to take your raw data and turn it into information. And turn to information. Like, what's the mean? What's the median of the data set? What's the standard deviation? What does the histogram of the data look like? Then after you've explored the data and you just have it as information, then we're going to go into step 4 of the process. And this is draw inferences and formulate conclusions. This is section number 5 of the class. So it's funny, right? It's like, well, Matt, you said the course is 5 sections long, but in the process of statistics, you only list that we're going to use section 1 and section 5. Well, to be able to go from section 1 to section 5, you need to have a good understanding of sections 2, sections 3, and sections 4. Like they all build on each other. Okay. And this draw inferences and formulate conclusion. This is how we turn information into knowledge. Okay, this is like, what is the data telling us? Like what story is it telling us and what can we conclude from it? And then one of the most important process or steps in the process is this reflection, kind of a look back on it. So we're not going to spend a lot of time doing this in our class. We'll do it a little bit today, but it's really important to understand the limits of statistics and what you can conclude from data and all the little intricacies of it. And what I want to do next is I want to walk you through a statistical study through all the steps here. And then I want to show you, how do you explore the data, how do you collect it, what conclusions you make, and then why the reflections and looking back are really, really important. Okay. So I have this example here. It's a little bit of morbid, kind of macabre example. But I want people to think about this as we go through this, okay? This is about organ donation, okay? And forgive me, I didn't have a poll set up to this. But how many people in the chat, I'd appreciate it if you were to answer honestly, okay? There's no judgment here. How many people think organ donation is like a good thing? Having organ donors in our society is a good thing. Yeah, okay, all right. Okay, a lot of people are like, yeah, it's a really good thing. It's good. I'm an organ donor, okay? No judgment if you're not. It's not a big deal. So like looking in the chat there, like almost everybody, it seemed, there were a ton of like, yes, it's a good thing. It's a great thing. How many people are actually organ donors? Okay, see? Okay, isn't that interesting? Right, just in the chat there. Like, let's just talk about this for a second. It looked like a ton of people said, oh, being an organ donor is a really good thing. Like, yes, organ donor is a good thing. But then like when it was like time to say who's an actual organ donor, did you notice that the participation dropped off? Okay, did you guys notice that in the chat real quick there? It's an interesting phenomenon, actually. And forgive me, usually I do a poll for this, but I didn't have time to set it up. And usually what ends up happening when I teach this in person is like 90 to 100% of people in a class say, yeah, being an organ donor is a good thing. And then when you go to ask people, yep, I'll talk about that, Rebecca. When you go to ask people like how many people are an organ donor, it ends up being like less than half the class is actually an organ donor, okay? Just 1 second. Does anyone know how you become an organ donor? Okay, Melissa has it right there. The vast majority of people become organ donors through a simple application process on their driver's license. Okay, just out of curiosity, is there anybody in here who does not live in New York State? Where do you live, Melissa? What state? I'm just curious.
I'm in Connecticut.
Connecticut, okay. Is anybody else? Okay, so so that's great. Most people are from New York. I actually live in New Jersey. Okay, so I'm in the Great Garden State, and we're actually going to compare our two states when we talk about this. Okay, so let me read you this. So even though organ donations save lives, recruiting organ donors is difficult. Okay, so interestingly, surveys. National surveys, scientific surveys, so that 95% of Americans approve of organ donation in principle. And many states offer a simple organ donation process when people apply for their driver's license. And I'm going to talk about how it's done in New York and how it's done in New Jersey as a comparison in a little bit. I actually don't know how it's done in Connecticut, Melissa. So, as we go through the process, maybe you can chime in and let us know if it's like one of the two that I discuss. However, only about 54% of licensed drivers in the United States are registered organ donors. So think about that, okay? 95% of people say it's a good thing, but only 54% of people are actually organ donors, okay? Why do you think it's hard to recruit organ donors? I'm just curious. Anybody have a guess? Like you can turn your mic on or post in the chat. Why do you think it's hard?
I wonder if people don't know exactly how to do it. Like I know it was on the license for my or the application for my driver's license, but I wonder if some people don't realize that's part of it.
I'll talk about that in a little bit. Yep, there could be religious reasons, but like the thing about that, Rebecca, is like if 95% of people think it's a good thing, but only 54% of people do it, like there has to be some other reason for the disconnect, right? Because like if there were religious, okay, that's a good one there. Fear. Well, like when you say fear, what is it that you have to think about?
Maybe they may not save your own life if they need to make some effort to save you. Since you will be a donor, they would prefer to harvest your organs unless you die.
Maybe there is a fear that maybe they'll see my license and not save me. Maybe, yeah, that could be one. But I think what research actually tends to show is people don't like to become organ donors because you have to think about something unpleasant. Okay, but like for example, when I choose to be an organ donor, what do I have to think about happening? Yeah, that's it. I have to think about what's going to happen when I die. And like no one likes to think about that, right? Like it's very, it's an unpleasant topic to think about. Okay. So here's the thing: organ donation does save lives. For whatever you think about it, doesn't matter. We want to increase the participation rate. Or researchers say, okay, look, there's a huge disconnect here, and perhaps how we phrase the question or how we present it to people will affect their willingness to become a donor. Okay, so what I want to do is taking this organ donation process, I want to run you through these 5 steps of statistics and show you how, research question was asked, collect data, explore the data, conclusions, and then look back. So you can kind of see the process at work here. Okay, so this simple exercise here is going to be our first look at how we solve problems in this course. Okay, so this question here is going to actually follow an actual study done out of Columbia University. So there's a link there if you want to read the study. Okay. So I want to tell you, give you an overview of this. Okay. So these professors at Columbia University said, okay, I think if we presented the application process to people, or presented or changed how it was presented to people, they might choose to be an organ donor. Okay, so here's what they did. They recruited a bunch of students at Columbia University. Okay, these professors put out this call, and they said, hey, will you please come be part of this study? Okay, and so a bunch of these students showed up, and they didn't know what they were being asked. Okay, this is important. They just know that they were going to be part of a study. They did not know what it was about. And so what they gave them was they gave them a driver's license application that they needed to fill out. Okay, and it had all the normal questions on it, like where do you live, what's your eye color, what's your height, what's your weight, and then they took the students and divided them up into 3 different groups. Okay. And and how they asked them the question about being an organ donor was different, all right, in each group. Okay, so they wanted to see if the question, how it was phrased to them or presented to them in their driver's license application, if it impacted their willingness to be an organ donor. Okay. All right, so here's how the options were presented to them. Okay, so some participants were forced to make a choice of becoming an organ donor or not. Okay, so they weren't presented with a default option. Like when they went to go present their driver's license application, they had to answer this question. Okay, so this is what we call the neutral group, and they had to answer. Okay, so I moved to New Jersey actually from New York. My wife is a Jersey girl, so obviously I had to live in New Jersey. So when I went to, they actually don't even call it the DMV, they call it the MVC here. So when I went to the Motor Vehicle Commission, the MVC, and I filled out my driver's license application switch, I was talking to the individual at the desk, and she goes, okay, sir, please answer this question. Okay. And it literally popped up on the screen in front of me, and it said, do you want to be an organ donor? Yes or no? Okay. So I had to make a choice. Okay. So this is how it's done in New Jersey. Okay, my new home state. Okay, so like I had to choose. Okay. Just out of curiosity, for those of you who live in New York, was that how it was done in New York? When you guys
Yeah, I think so.
I thought it was like on the paper that we had to really fill out.
So it was on, that's the thing, whoever said that. Yep, a lot of you say you don't remember it. Here's why. On your paper, when, at least it was for me, and you got it. I'm in my late 30s, I'm almost 40. So like, this was a long time ago for me. But when I was doing this, there was an option on the paper, okay? And what it said is, would you like to be an organ donor, yes or no? Now, here's my question for you. Do you think everybody who sees that answers it?
Nope.
No.
Not at all.
They don't. A lot
No.
of people leave it blank, right? So here's my question for you. What happens if you leave it blank? What is
Nothing.
so
Then you're not an organ donor.
you're not an organ donor, right? So New York State says, all right, you're going to leave it blank. We're going to choose for you. We're not going to force you to be an organ donor if you leave it blank. So this is the second option here. So other participants were told that the default option is not to be a donor, okay? But they could choose to become a donor if they wish. This is called the opt-in group, okay? So default, no. Okay, this is how they do it in your state of New York, okay? Just out of curiosity, do you think there would be some difference in participation rates between New Jersey and New York? Just on how it's presented right there?
Yes,
Okay.
it would be.
I'm not saying which state would be better, but which state do you think would be better?
New Jersey.
Yeah, look, I'm not judging you guys from afar, okay, but I am a little bit. So the Great Garden State here, maybe. Okay.
Haha.
Okay. So the remaining participants were told, this is the different one, that the default option was to be an organ donor, but they could opt out, okay? So there was another group where it's like, hey, look, you're gonna be an organ donor. So the default was yes. Okay, but you could say no. And I don't know any state that does that. So my apologies on that one. All right. Do you think that, so looking at this, so my question for you is the following, okay? Do you think there's going to be a difference in participation rates on how it's presented to people? Or should every group?
I think so.
Okay, maybe, I don't know. I mean, I do know, but can anybody guess which group might be the best? Which one might have the best participation rate? Two, do you think New York would have the best? Like what you guys do? New York? One and three. Okay, so here's the thing. Remember what the research is suggesting, right? Like people don't want to make an active choice. Okay, that's the truth. People don't want to think about their death. Okay, so maybe if your choice is taken away, or you know you're already, you know, if they say, oh, you got to be an organ donor, then maybe that's the best one. Maybe three. Or maybe one would be the best because like people, you know, oh, I got to be a good citizen, you know, but which one do you think would be the worst? Yep, I agree with Melissa. Yeah. So, all right. So maybe not, again, not judging you New Yorkers, but maybe yours is the worst. I don't know. So let's see what the research studies show. Okay. And then I'll talk about what happens in the real world in a second. Okay. All right, so here's the 5-step process, okay? First question, you need a research question. All right, so here was the research question Columbia had. Does the default option presented to driver's license applicants influence the likelihood of someone becoming an organ donor? Okay, so what we want is we want an answer yes or no here. Okay, we want to figure out yes or no if that's true. So the second step in the process was to recruit various participants. All right, so your data collection and experimental design. recruit various participants and ask them to pretend to apply for a new driver's license. Going to randomly assign them to the groups. Okay. Step 3, you're going to explore the data. So they had all these students answer. Okay. So what we need to do is we need to take the answer, take the data, excuse me, and put it into consumable information. Okay. So let me show you. And you can all see my mouse on the screen, correct?
Yes.
Yes.
Okay, so let me show you what the data summary looked like here. Okay. All right. So this right here, these are called cumulative frequency bar charts. Okay. And what you're looking at here is this represents 100% of the people in each group. Okay. So this is the opt-in group. Okay. Oh, the data link doesn't work. I'm sorry. This is, I'm sorry, Melissa. You know what? I'm going to be honest with you. This PowerPoint slide is a few years old and I haven't checked the links, but I'll fix that at some point. Sorry about that. Okay. So the opt-in group is New York. Okay. So this is how it's done in New York. Okay. And these are the proportion of people who chose not to be donors. Okay. So it's roughly 60% of people chose not to be donors and roughly 40% chose to be donors. What the actual numbers bared out in the opt-in group was roughly 42% chose to be donors. Okay. The neutral group where you had to make a choice, that's like New Jersey. Okay. And look at New Jersey, again, not judging you, but is there a big difference in the percentage here in the study who chose to be donors? Yeah, it looks like it's in this study. It looked like it was roughly 79% of people. I'm going to talk about it. I take the high road, but then I'll talk about what happens in the real world in a second. And then this is the opt-out. So this is where they say, hey, you're going to be an organ donor, but you can opt out. That's even the best group. Okay. That's at 82%. So here's my question for you. Okay. Everybody see that there's definitely a difference. Like are two groups pretty close and one group is pretty terrible? Can we agree on that?
Yes.
Yeah.
Okay. All right, good. Okay. So let's look at our results. What do you think? So is there evidence to support something? So my question for you is this. Does the default option presented to the driver's license applicants influence the likelihood of becoming an organ donor? Melissa says yes. Yep, Julia says yes. Yeah, the data seems to back that up. Agree? Yeah, okay, great, yes. Okay, so how it is presented. Does seem to impact. Okay, so great. So it's like, great, this study is amazing. We're able to conclude something. We should have, you know, a universal application process, okay? But now let me talk about what happens in the real world, okay? Just to go back to here, okay? In New York, the great state where you guys are, in reality, actually I'll write it up here. This is the real data. In New York, roughly 35% of applicants are organ donors. Okay, so that's what the real world data bears out. Okay, so New Jersey, which does it differently, okay, the Great Garden State. Do you think we're actually that much better than you, or do you think it's pretty close?
It's close.
But we present ours different though, right? Like,
Yeah. But again, I feel like as well as it's presented, there are some people that would not become organ donors or just simply just press no.
yeah. Okay. So as much smack talk as I was just doing for the last 10 minutes, it's only about 40% of people in New Jersey are organ donors. So, hey, I know. Look, I had to get it in while I can because New Jersey takes a lot of beating. Okay. I'm just curious. Does anybody have a guess what state is the best, as the highest percentage of organ donors? It's not California. It's not Florida. It's not Vermont. It's not Texas. Wait. Melissa, which one do you think it is?
Montana.
It's Montana.
Oh crap.
Can I just say something? I've been teaching this same lecture for like 5-6 years, and I've never had anybody guess that. So that's a first one. It is Montana. I wish I could tell you why. I'm not sure. But Montana's is like 88% for some reason. I don't know why. Okay. I'm not even gonna form a guess. So here's the thing. I've never had a student guess that. So they're an odd and interesting state. I've never been to Montana. I've been to a lot of states. I've never been to Montana. I don't know. I tried to look how it's presented on their driver's license and I couldn't figure that out. So I apologize for that. Okay. Anyways, so here's the deal. This study is saying that how it's presented should have a large impact, but in reality, it doesn't bear out that way. Okay. Like New York, the study said it should be around 42%. It was pretty close. The study said New Jersey should be around 80%, but in reality, it's not. Okay. So this is why, just going back real quick, whenever you see a study, okay, and this is one of my hopes from today's lectures, like whenever you see a study, and the study comes out and they said, look what we can conclude. You got to really dig deep into the study and really look at some of the limitations to it. And if they're really making the right conclusions. Okay, so there's two issues with this study. Polling, the sample size isn't the issue here. Sometimes in the real world, really actually sample size just really influences the margin of error, not necessarily. You can ask questions, Zoe, if you have your hand raised. Anybody have a guess as to the two issues with the study here?
I have a guess. Do you think it has to do with the fact that the study is all college age kids and they're more inclined to click yes for organ donor than maybe just the general public?
That is exactly one of them. That is great. So here's the thing. This is where it gets even more tricky. Okay. This study can only really say something about who did they interview for this study? Students from where? What university? Does anybody remember?
Columbia.
Okay, now here's where it gets even more tricky. They only sampled Columbia students, and they only sampled Columbia students who are willing to show up for a study. So their results are really only applicable. You could really only say something that these results are only transferable to Columbia University students who are willing to participate in a study. So is there something different about Columbia University students than the rest of the world? Yeah, demographic. Like, and I can say assuredly that yes, like Columbia University, there's something weird going on with them. Okay, I can say that because my wife went to Columbia. Okay, it's true. Okay. There's another issue with this type of study. And this is a big issue in the real world with polling and studies like this in general. Okay, there's something that this study has, which is called response bias. Does anybody have a clue what that is, what that might mean?
Is it that they might want to give the quote unquote right answer when they're doing something like this?
That's it. So what happens is whenever you're asked, given a study like this, you know that someone's going to take your paper, your driver's license application, and they're going to judge you. Okay, they're going to form a conclusion about you. So there's a tendency to do this thing called response bias, is where you give the answer you think they want. Okay, so this is just a study, so there is no impact in the real world. So like you come to this study and you see this question about organ donation, and you're like, oh yeah, I want them to think I'm a good person. So I'm going to say, yes, I want to be an organ donor. And then it's just like, well, it doesn't really matter if I say yes, because in the real world, I'm not an organ donor. So, you know, that's a big issue with these studies. So I hope I hope you can see, like, you know, how you perform an experiment, analyze data, form conclusions, and why it's like incredibly important whenever you see a study or some statistical conclusion in the news to just take a step back and say, okay, is that really what's going on here? Okay. All right, an interesting example. What do you guys think? Kind of fun? I hope so. I like doing that problem. I think it's a little bit morbid and macabre, but I find it interesting. Okay. All right. So now what I want to do, unfortunately, is I have 18 minutes left. So what I want to do is I want to start talking about some key definitions in this class. And this is incredibly important. The definitions that I talk about in this class, because they're going to come up every single day. Okay, so it's really important to pay attention, maybe jot some notes down here. So in statistics, there are two types of data sets that we can deal with. The first is what's called a population, and the second is what's called a sample. Okay, so here's some key definitions. So a population is a collection of all items of interest or under investigation. So what I like to think of as a population here, a population is a complete data set. Okay, you have all, or you know, all the possible data values. Okay. So we want to start putting numbers to things. So whenever you see a capital N, and don't worry, I'm going to do an example in one of the slides here of a difference between a population and these numbers here. Whenever you see a capital N, okay, this capital N is going to represent the population size, okay? So capital N, how many data values are in the population? Okay. In this class, we're actually not going to be working with population data that much at all. The reality is because it's like, oh, you have all the complete information. That's just the, you know, whatever the mean is of that population is the mean in general. But what you're going to notice in the real world is oftentimes it's like not even feasible to talk to everybody in a population. Okay, so what we do is we take what's called a sample. And a sample is an observed subset of the population. So I like to think of a sample as incomplete data. Okay. Think of it as like a small observation of the population. Small observation of the population. And we're going to let, and this is a subtle difference, but it's like incredibly important. We're going to let lowercase n represent the sample size. Okay, so lowercase n is how many data values are in sample. Okay, and you can think of data as values, measures, or categories recorded on individual entities of interest. Okay. All right, these are two other important definitions here. So a parameter is a specific characteristic of a population. Okay, so a parameter, what a parameter is, it's anything calculated from a population. Generally, okay, Generally, parameters in this class are going to get denoted with Greek letters, okay? So that'll be a dead giveaway. There's really only two that we're going to use in this class. We're going to use this Greek letter. It looks like a U. Does anybody know what Greek letter that is? We not up on our Greek alphabet?
Lambda?
Nope. Who guessed though? It's the Greek letter mu. Okay, it looks like a U. And then we'll use this one a little bit. Looks like a sad 6. Okay, does anybody know what Greek letter that is?
Standard deviation.
It's going to represent the standard deviation. That is absolutely correct. But it's the Greek letter sigma.
Oh, sigma, yeah.
Yep. Okay, so whenever you see these notations, what it means is it's going to be like, hey, we calculated this value from a population. Okay, and I promise you, when we get to like next week and you start seeing these like formulas put to them, it'll make good sense. Now a statistic, and this class is called statistics. A statistic is a specific characteristic of a sample. So a statistic is anything calculated from a sample. Right, and really what this class is going to be about is how can we use statistics, right? These things calculated from a sample to say something about the general population. Okay, that's where we're going with this class. Okay. All right, is everybody okay if I go to the next slide, next few slides?
Yep.
Anybody else? Let me know if I go too fast or if anybody needs me to stop or pause. I have a tendency to go fast sometimes. All right, so just so you can understand the subtle difference here between a population versus sample. Okay, I know this seems weird, but suppose you take the letters of the alphabet. Okay, so how many letters are there in the English alphabet?
26.
Yep. So the population size of the letter of alphabets is 26. Okay. Now suppose the letters of the alphabet, okay, are paid a salary based on how much they're used. I know it seems silly, okay, but like A makes a lot of money and Z doesn't. Okay. If you were to calculate the average income of these salaries, or average income, excuse me, of these letters, that would be a parameter because it comes from complete information. But instead, suppose you took a small sampling of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 4, 6, 9. Yep, so our sample here, our sample size is 9. If we were to calculate the average income of this sample here, this would be a statistic. Okay. So you can kind of see the relationship here between a population and a sample. Like it's just, if this is the entire population, okay, this is just the small subset of it. You just randomly, you're going to take the few individuals from the population. Yep, I can go back real quick. Okay. And anything calculated from this population, that's what we refer to as the parameter. And anything calculated from a sample is called a statistic. Okay. Let me give you a real world example of this. Okay. So this is done in survey research and polling, right? So I'll talk about this a lot in this class because it's the most visible application of this that you can like see in the news. Okay, so political polling provides an example of inferential statistics, right? Like interviewing everyone of voting age in the United States on their voting preference would be expensive and unrealistic. Like you can't do it. Okay, statisticians who wants to gauge the sentiment of an entire population of US voters can really only afford to interview a carefully chosen group of a few thousand voters. Okay, and this group is called a sample of the population. Okay. So let me give you an example of a real world poll, okay? So Unfortunately, you guys are going to hear me talk about or pull polls from Rutgers University. Have you guys heard of Rutgers University?
Yeah, in Jersey.
It's in New Jersey. Yep,
You
Rutgers,
know what?
just the State University of New Jersey. So you guys obviously can tell I talk about my family a lot because I've referenced my son and my wife a lot. But my wife is a pollster actually at Rutgers University. Their football team is terrible. So this is a poll that she actually recently did. Okay. And so what she said was that 2/3 of New Jerseyans feel state is moving at the right pace to open. So this was about the pandemic. So do you think my beautiful and talented wife was able to talk to 2/3 of everybody in New Jersey or talk to everybody in New Jersey? And
No.
no, like there's just like no way she could. Okay. Like you can't do that. But like her poll wasn't wrong. Okay. The 2/3 of New Jerseyans did feel this way. And so what she did was she took a sample of roughly 1,500 adults. So you can see that's her sample size. Okay. And what she's doing is she's drawing conclusions based on everybody who lives in New Jersey. And this is the rough population size of New Jersey. Right. And what this course is going to be about is, I want to show you is how is it okay or correct to draw conclusions about a population like all the people in New Jersey just from a sample. Yeah, I think it's really cool. There's a lot of good stuff going on in this class. And then that's where we're driving for in the coming weeks. And so actually I'm gonna, instead of being disjointed and starting the next topic, I'm gonna stop the lecture here. I hope that's okay. I just don't want to start the next topic and break it up. Okay, yep. So here's what I'm going to do real quick. I'm going to stop the recording and I'll answer that question. I'll answer any last minute questions. So let me just stop the recording.